All right. Oh, the class is in session. The bell has rung. Welcome to another episode of I. Lucky, how you feeling, brother?
Well, I'm feeling like a little bit of echo. We've had some technical difficulties today, but today we have a special guest in studio. Drew, a personal friend of mine. Um, also, we work together as instructors, but today we're going to be sharing the big bright world of AI and how it's changed. But before we get into that, Drew, thank you for being here, my friend, for being here early. Early. It's
Oh yeah.
it's 9 o'clock. Thank you, my friend. Welcome.
Well, thank you. It's an honor to be here. I'm always happy to have an audience, and it's an honor to be able to share some of my experiences, and hopefully your audience will get something out of this session here. So thanks. Good to be here.
Well, Drew hasn't experienced yet how the I chant starts.
Oh, I know, right? I hadn't done it. So yeah, the fact of the matter is that we all have to start a certain way, right? At the end, today
Right.
is tough, right? Like I. But at the end, I know that we're going to be like I. We're going to learn so much today, and but we're going to try to take it in small bites because at the end,
Right.
we can only process so much. This stuff is, it's AI, but we're going to try to make it as palatable as where you can understand it. And Drew's really good at being able to make things and deliver the truths about what is AI. So, what is AI? Asif, we've talked about it a lot. AI, it helps you at some point make better decisions. It can also empower you to do things that you didn't thought were possible, see things that weren't possible or weren't there, develop things. And now we're trying to figure out, okay, where did it change? Because I remember AI was just three basic things, and before we get into it, it was AI, it was deep learning, it was machine learning, but now we have all new different terms when it comes to AI, and it's changed in 6 months. So what's changed? Asif, what do you see? I mean, it was real easy before. It was AI, and AI was derived from deep learning and machine learning, and then eventually you would get to some kind of neural network that would give you AI depending on what you were trying to design. Now we have generative AI, and AI that supports large language models, and that's totally replaced that whole thing. What did we know was AI now has become visual, it's become hands-on, it's become more relevant. And what's changed? And so I think today is a good point to understand, what when it comes to deep learning, what do you see, Asif, and
Yeah.
Drew? I mean,
Yeah.
I think that's a good place to start.
Yeah, I think I'm going back in timeline and looking at the history in my head and saying like, well, hold on. I think even with some maybe a word of advice from Drew and some backup from Drew, I can say this very confidently. Nothing has changed. It's just people's perception has changed, right? People's ability to engage with that technology has changed. So matrix manipulation is the ultimate neural network, right? That ability to say, take all sorts of data and manipulate that data to give you an output, right? That has not changed. And that doesn't have to change. That's not where change is. The change is happening in the middle, the hidden layer, that neural network, whatever that you want to call it, the black box, right? That matrix manipulation is just putting out an output that we haven't previously been able to say, well, this is what this output feels like, right? Input is the same, hidden layer is the same, black box is the same. It's that output, the way it's being perceived is different. So um, I am an optimistic guy. I'm all in for AI machine learning, but I have to admit, AI is just a marketing ploy, right? Has lots of marketing necessity behind it. Somebody's trying to make that million into billion. Well, you're not going to be able to do that by selling the same stuff over and over. You have to relabel it. You have to capture the market, pursue the market to call it, this is fresh and innovative and on the edge, right? Well, if the speed has changed, that means you're no longer driving a Toyota Camry. You are driving an F1 NASCAR, right? That ability to engage with the customers to say, this is not fast as your old AI. This is faster than all the other AIs that you have experienced, right? So that process of relabeling is what we're experiencing. But ultimately, the under the hood, it's just a faster engine. It's just an engine that is able to fine tune and optimize itself, right? Those are the things that we're looking at, right? Um, as you were going through the whole breakdown, I just wanted to say, like, this classroom in session right now is for Drew to teach. You know, I'm the student. Lucky, you're probably the student too, but you're lucky enough to be right next to the professor here. But Drew, what what can I add, or what did I get wrong?
Well, just to, there's two things that are talking right now that I want that are topics I want to pull out. Right, one of them is that there's a definitions challenge. I think that that Lucky started with of saying what has changed and how do we reconcile our vocabulary, right? And then to kind of where both of you are headed is trying uh, to true up on, with for, if you want to just be technical terms, right? There's a lot of action in large language models. I would argue that when you start looking at ChatGPT 4 and where things are headed in just the deep learning space, right? The what has made things exciting is that the level of generative AI, whether it's with pictures or with text, has become asymptotically more complex and reliable compared to, say, I can remember in 2018 when I was working on the data science project, the exam work in Microsoft, talking to the lead data scientist that was from the revolution analytics work. And natural language understanding was still something that Microsoft was trying to say, hey, this, if you use our framework for our chatbots, right, this will at least help you make sense of somebody putting a random phrase in and then having be able to train it on a particular sort of framework of a conversation that you're building from scratch, right? We've leapfrogged that in the last 5 years. But I mean, to take a step back, right? I mean, to talk about disambiguing language, right? When I talk with students, through the Divergence Academy, the veterans that I help with the Divergence Academy there, I usually tell people that it used to be called, when I started, was data mining, and then I still use the word data science when you're looking at tables, which is not very exciting these days. That machine learning is anytime you're trying to use some type of algorithm where you're predicting, you're having a simple output like a column, like a yes, no, or a regression target, but the feature space is more sparse, right? Instead of having rows and columns where you can, it's a problem if there's something that's null or an empty field, right? When you get into pictures and you get into text, right, your feature space is no longer hundreds or thousands of columns; it's hundreds of thousands of features, and they may be tokens, that are text for like a document term matrix of the unique terms, depending on what size you put your n-grams in, for what they call tokens, in NLP, or with the actual pattern of a particular set of pixels, right? Going back to what you were saying, when we talk about deep learning, right? I mean, the original hidden layer work that was, goes back to, I think, the 50s on cognitive science, on having hidden layers, right? That didn't get thrown out in 2010 at the University of London in Ontario, Canada. What happened was is that they decided, look, having just one X number of hidden layers of a wide layer was not computationally sophisticated enough for the type of work we need to do. So Deep learning was to be able to add kind of having a library of other ways to compose different variations of relationships between those networks, right? You're right in that, when you look at a convolutional neural network, right, you're still doing matrix algebra to do the convolutions, or in visualization terms, right? People will take pictures and run it through a pasta machine, take every other strip out, and then do that a second time to make 4 individual pictures, right? As a way to have show a physical convolution, right? Nowadays, for image detection, there may be 150 of those with some residual feedbacks for ResNet, right? As far as how you get to really good precision along those lines to be able to handle rotation and stuff like that. But so when I talk about artificial intelligence, that's essentially what I call machine learning. And when you're trying to do something fancier than a yes no answer, like a classification or a multi-class or a regression, right, where your output is something that's of a wider range, of more dynamic, a more human range of features, right? In other words, the classical one would be what they call now a sec-to-sec or a sequence-to-sequence transformer. In other words, that you have a variable range of inputs, and then you get a variable range of outputs, right? This is where Google has ultimately rewritten a lot of their translation software to have this interim representation of language that is not, it doesn't mean anything except for on chips and in the actual embeddings of the feature space of all language, to be able to say, this language can be translated this one through this step, right? But kind of catching up, one of the things that has empowered that ability to have these sequence to sequence models become more mainstream and much more accessible is the recent invention of a transformer, which is essentially, it's got its roots in the sort of the forecasting innovation in deep learning, or the long short term memory idea of having, looking at in old school RMR, like for forecasting, you had to, for one run of a model, you had to choose, okay, X number of features, you go back like six periods of time, and that's all you get for one run. LSTM said, okay, look, we'll give you a range, and sometimes you go back 1, 2, 3, 5, 6, whatever you need, in order to find where the sweet spot is for your messages. And kind of that abstracts, when you're looking at fancier feature space, into what we call attention, as an autoregressive general way of representing any type of relationship of features. And that is a fundamental building block of transformers. Has really only been out since I think most of the main research was happening about 2019 and became mainstream in 2020, and that's when Hugging Face and Transformers as general purpose libraries exploded. And so that's when we started to see a lot of this next wave AI, and it feels like it's brand new, because the reality is that every vendor, like insurance, right? You watch TV and you got 5 different insurance companies that are selling the exact same product, that only have their ads to be able to hook you, right? Um, and analytics is no different, right? Everybody is trying to say that I have something that makes me relevant, right? Now, there are some better cases than others. Like, as an example, H2O and Databricks are both companies that have machine learning or AI as part of their product. They have very different business models, but both of them decided to take a large language model and be able to build what I would call a mini model, right? In other words, they took an open source billion parameter one, and then made one that they trained for a specific type of work, to be able to let you be able to use it for kind of some specialty type of conversations, right? For Databricks, it was Dolly. For H2O, it was H2O GPT, right? But essentially, those are just ways so that instead of you sending, like at Apple, right? Apple has banned all their employees from using Chat GPT, because you have no control over how your searches in aggregate are used to be able to infer what type of research you're doing. I'll tell you that the Chat GPT engine is not, the more the rarer the type of conversation you're trying to have, the less good it is, right? I mean, I think there's been
Right.
cases where someone tried to do a legal, he used Chat GPT to make a legal brief, and I think there were six precedent cases that didn't exist, right? In machine learning, we used to call it, oh, that's feature hashing and collision, as far as feature hashing being able to compress billions of rows of different states into maybe 10 million, 16 million, what have you, and then have them all be the same otherwise. And then collision is when you get things that don't match, but it comes up as hallucination there. So I mean, that's kind of I think that the generative AI is really taking, it's basically making a, because deep learning was really esoteric in its first, I would say, because I mean, it really hit mainstream probably about 2015, with TensorFlow, and then PyTorch has become more popular in the last few years, um, as because it's a lot, you can do more things in runtime instead of just compiling and executing. But essentially, it was the idea that you had to roll your own model and build it by yourself, and you weren't really taking advantage of what they call transfer learning, right? Nowadays, what's happening is that between there being standard what we call sentence transformers, where essentially the word embedding. When I was doing it in 2019, we had this thing called Glove that's now just completely, it's basically three generations behind in 5 years, pretty easily. You know, um, it was very clunky. I mean, especially during COVID, trying to rent a GPU that could run the thing was
Right.
just, it was, I think I went through five different vendors before I got on the, I got a spot check with AWS on it. But the main thing, just to end on the what's new, is that generative AI is really what I would in technical terms, it's a special case of the sequence to sequence transforming and transformers. But what makes it eye popping is the amount of data that they have trained it on is so massive that the barrier of entry for doing big work has become much harder to do. I mean, Apple still doesn't have their own equivalent of a Chat GPT. AWS doesn't have their own, GPT. So you basically got Bard, which after $100 billion dip in their stock on a bad product launch, may have lost some traction. So it's kind of like OpenAI under the Azure flag, and Bard are pretty much the only monoliths right now. So let me just stop right there, because I've said a lot, but I think I answered um, uh, Lucky's two first questions there.
Yeah, I think folks, if you can't hear it, or if you're watching this, that means attention is all you need. Attention is all you need, not just for a paper that was written back in the days, but attention is what you need in order to keep up with this AI machine learning. 5 years, three different generation. That made me laugh. Like, that is just hilarious, because where else are you seeing that much movement this fast? Where else? I don't know. Maybe F1 race car. Who knows? Right? It's fast. Attention is all you need. However, Lucky, I know you have a lot to discuss here, but I just want to point out what Drew mentioned about yes or no.
Hmm.
Right? That is your ultimate core of starting in whatever the business logic, whatever that personal life improvement, or whatever the use case you're looking for. Yes or no is where it all starts. A good question. If you're able to ask the question that is based on the use case, and implication of that question will run you for a very long time. It will suppress that 5 years of three generation. Because if you ask the wrong question in the very beginning, you will end up chasing your own tail. Excuse me, let me get more professional. You will end up chasing a business logic that you no longer have need for down the road. But if you ask the right question, that business logic will serve you forever, because things are moving so fast. The question you asked is what's going to serve you in a long term, and the question is what's ultimately going to provide you with an output that you will say, "Yep, that was our success story." So, Lucky, what'd you think?
No, yeah, I agree. There's a lot of different points that we made, and Drew, you kind of hit on one that I personally am dealing with, and for the most part, AI is growing so fast that how do you apply it? How do you apply it into your work? Your day to day work. Um, I've talked to people now, doctors, researchers, and where before AI was something again from the movies. Now we've got doctors, just researchers, everybody wants to use Chat GPT, whether it be 3, 4, 4.5. People are already excited about what version 5 is going to be, and and you brought up a good point. One thing is, yes, it's fantastic. It helps you. It makes things easier. It opens your eyes to, simplicity. All of a sudden now you have something that can help you finish a thought or start a thought. Or before you, if you have writer's block, or if you just don't know, where to how to get something started, all of a sudden, boom, there it is for you, right? And then it gives you everything. But the problem is, again, is when you're doing those types of searches, when you're, what's being fed into the AI, because you're getting something back, but what's being fed into it? And that's a big problem when it comes to security. And that's something that we still have to figure out, how much how much data, is the AI when we ask a question, when we frame a question, how much of that is being held for example, a profile for a specific company, or if you're work for the government. At the end, you don't know what data is being or what they're developing as far as information from you. So yes, you're getting something from AI, but what is AI getting from you? And we haven't figured that out. And that's something that it's a big question for me, and I'm sure for people out in the private sector, and that's where, like you said, Apple said, you know what, we're not gonna allow people to use Chat GPT. That's that's going to be the norm. But why? Why is it the norm? Is it really, you know is there something in the background that's much like when we see Siri, when we talk, and all of a sudden we're seeing advertisements in, our social media? What is the blend there? I think that security, from my point of view, is we have a lot to go still. We still have to learn from AI, and there is an exchange right now. We're just seeing the front part of the exchange. We're getting something cool. We're getting responses from AI, and it's fantastic. Have to have those, have that conversation. But I think there's still a lot to go with understanding. What are we giving up when we communicate with AI? There is a back and forth, and so you definitely hit a good point, Drew. That at the end, there's going to be a lot of growth. I'm still working on what are the guidelines for setting up what is AI, for people, so they understand that, and that's where we're at. So without being long-winded, again, there's a lot of scary stuff that's still happening in the background with AI. How was that model designed? Yeah, we can trust Chat GPT, but how many other large language model companies are there? That are there, what, dozens? What exactly is the exchange, and then what was the data? And you mentioned that they there is large language models, and they're training smaller models to have very specific use cases, to be able to solve certain things, or work in certain areas. That's fantastic. There's going to be more generative AI, and I get to the point is we as I was just a data scientist. I was a data guy, a data warehouse guy, and there's a separation of what data science is, and then what we started developing the AI. Well, we're past that. When I'm getting to the point is, I only saw AI as being two, three basic things now, and the world doesn't see that anymore. All they see is Chat GPT.
Right,
Chat
right, right,
GPT, man, and it's
right.
fantastic. And they see the generative AI with like stable diffusion. That's the new stuff now. That's what people see. They're not ever going to understand that AI, there's a back end of data learning, deep learning that's happening in the background. They just see the cool pictures, and that's where it's current.
Yeah, I think lucky as you mentioned that I'm thinking of analogies. I'm thinking of like how to draw that picture, and of course, I'm going to go back in history, right? Um, you know, history is just it's repeating itself. This is
Hmm.
not really. My goodness, my Siri, my Siri just turned on because I said something about I don't know what I
Yeah,
said.
AI, man. Siri's there. She wants to be part of the conversation.
Siri wants to join into the podcast. Maybe we'll
Yeah,
have her as a guest next time, right?
yeah. Drew and Siri.
um, driven Siri. I know that historically, like if you take that the paper attention is all you need, and you just take that word attention. What does attention do, right? Attention focuses you into a single topic. So let's say, for example, you're looking at history and you're looking at Roman Empire, right? Well, if you think about Roman Empire and your attention span starts with Roman Empire, you're really not going to focus on what other empires was around when the Roman Empire was around, right? Roman Empire did not have the whole world. Roman Empire had piece of the pie, right?
Mhm.
What about the rest of the pie? Where did that go, right? And as you go down that rabbit hole of where our attention takes us and how all the bubbles around the big bubble that we don't see, for example, ChatGPT being the big bubble, what are other bubbles that are around it? The micro bubbles, the small bubble, that tiny bubble, that medium sized bubble. You lose focus because that's not how your attention works. Your attention works on what it is that you're focusing. If it's AI, you're not going to think about machine learning. If you're thinking about machine learning, you're not really thinking about data. If you start focusing on data, you definitely going to lose sight on machine learning, right? Because your ultimate starting point is where you will end up in. But it's necessary that we use our human nature, the nomenclature that we have in our brain. How do we utilize that nomenclature for good, for better, for advancement, for research purposes, for just improving it, whatever the case is? It's the attention that actually matters. So if you're attending, just be aware of the fact that your attention is where you will end up in next.
Mhm.
And at this point, ChatGPT being the source of all attention, look, we just talked about Apple earlier. Well, the reason Apple did what Apple did is because Samsung found out in a bad way that their coders took the open source code and put it in ChatGPT. And there's no way of retracting that. ChatGPT is not going to come back. It's like, you know what I learned? Let me unlearn the source code from Samsung, right? And that's
Yeah,
the lesson everybody's learning, right? So
exactly.
the core of focus of security. If you start with security, you're going to go down the security bubble. Where in ChatGPT, they're able to integrate and optimize so many different AI system, right? So before ChatGPT.ai, there was Rider.ai, Coolbot.ai. There was all these other little mini AIs that were out there. Now ChatGPT has been able to optimize that to a bigger bubble. So those mini bubbles are still serving. It's just that the core of it is ChatGPT, right? So the AI that is coming down the pipeline, look, it's not going to be any different, right? Because history repeats itself. All these formulas and theories we have, they all just will repeat itself, right? As in, you will always have that big dog like Microsoft and Google somewhere in the bubbles, but there's going to be millions of other little bubbles surrounding that in order to either compete with Microsoft and Google or add and supplement to what Microsoft and Google will provide as a service, right? So it's and I guess this is my last statement here. All of them matters. All the bubbles matter. All the little dots matter. All the things that you're focusing on matters, right? But to reflect back to what I said earlier, it's the question that you ask is what's going to lead you down the path to the next level.
So let's do this. Let's do this. So we always kind of talk about what's current, but in AI and we cover the news. But what I'd like to talk about maybe is take advantage of Drew, is try to understand better large language models a little bit more precisely, because we all right now large language model, boom, it's the buzzword, but before that it was natural language processing, right? And before that, but so let's just take a step back. How if Drew, can you just give us a better understanding of maybe step us through large language models a little bit and maybe the history, or maybe just your experience, because again, you're the expert, brother, you're the subject matter expert. And when it comes to large language models, we can talk about anything generative AI, but large language models are something that's a buzz right now. So let's just take a step back and try to understand that a little bit better from your perspective.
So you know, the process to do a mini, basically the way you could look at it is that you could look at it, you could argue there's sort of mega models, mini models, and micro models is a way to look at how the ecosystem is, kind of that, extending your bubble metaphor, right? In other words, for example, right, if you want to be able to take advantage of the learnings of Chat GPT-2, Chat GPT, X, right? One of the first things to do is to have the core um, way of being able to take generic text and be able to have it be meaningful for any derived models from that same family, right? So that's where you talk about the specific model is some version of a sentence transformer specifically, but in general, transformers themselves are kind of a class of models that do the word embedding. In other words, to take your vocabulary and how things are used with other words as far as their context, and be able to say, okay, when you're talking about gardening, right, these things, these are nouns, these are verbs. Some things are good, some things are bad, that may not be core terms, right? So it's essentially learning your specific lingo in the context of the other, the bigger models, right? Okay, so you have to have, that's one component of sentence transformer that you need, right? Another one that's very common, and I'm talking about kind of pre-processing before you do the big training, right? Another one that's very common when you're bringing your own data is doing text summarization. In other words, if you're taking raw transcripts from conversations from tech support, right? People talk about their grandkids. People will just complain about the product, right? And so, at least trying to like narrow, basically trying to at least summarize so that, kind of like how you do in traditional feature engineering, right? You dean, you cut, you either cap or transform to get things to be a more normal curve, right? So those are the two sort of main pre-processing steps from an engineering standpoint, right? If you go even further up, right, ultimately, when we look at how these Chat GPT models are trained, they're really trained at the end of the day, and this may be surprising, right? But just as an example, right, in Dolly, right, this is Databricks work, and what I'm describing is something that I've been working with, as a partner in the Databricks ecosystem, building a solution. We're building a practice around LLM. In fact, there's a hackathon at the Data and AI Summit where we're taking the Dolly basis and H2O's LM Studio, and I'm creating what I call Dolly Llama, which is basically a studio to be able to help people write these Dollies, models like Dollies customized, right? So, I mean, anyway, so the point is that, at the end of the day, right, you really need two columns, right? You need a question and you need an answer, right? And it's not just because it's what it's doing is it's just understanding the delta of what your shtick, what your vocabulary, what makes your corpus of 1,000, 5,000, 10,000 question and answers different from whatever it was trained on, right? So that's basically, so those are kind of the things before you start doing real modeling, right? And then there's essentially, the most common scenario, and this is something that I've seen both in H2O GPT and in Dolly, is essentially using this kind of new class. And yes, I know, I mean, you think with data, using the term database, that you'd seen one database, you'd seen them all, right? But basically, there's an open source project called Chroma that essentially is what they call a vector database. In other words, what it does is it basically shreds your corpus and uses a sentence transformer to essentially take your document and represent it in a term of the vectors. It's basically a document term translator, if you will, and a storage mechanism for that, right? So, for example, you can ask basic questions just with running a sentence transformer and populating a Chroma DB to look for similar topics, right? You're not getting a lot of bang for your buck, but it's a lot quicker. I mean, it takes seconds with very little GPU clock time to be able to do that embedding and the search similarity, kind of like a cluster, search, cosine similarity type of thing on those documents, right? So that's the basic. So that's sort of a precursor step to the training, right? Now, for an example, the sample data set that we use is, I think, 1,500. It's 1,500 question and answers about gardening, right? But then we have the Dolly model that was trained. Basically, they originally took an Eleuther AI model. These are on Hugging Face, right? These are open source ones, and they, basically what what Databricks did was they got 15,000 question and answer directives from employees to be able to train it specifically to be a generic sort of chatbot specific interface as far as what it was, that what it took that mega model of the Eleuther AI and made a mini model that was for a question and answer, right? And so then the big thing where you need the big hardware. By big hardware, we're talking about you usually need about 24 gigs of GPU memory, right? Which that could be in three 8 gig machines or in one 24 gig machine. I mean, I'll tell you, in Databricks terms, between the AWS virtual machine and the Databricks licensing, for the DBU per hour, you're talking about $10 an hour to do this type of work, right? Um, I know that Databricks has mentioned, that they actually trained their mini model for $30 on, commodity hardware, right? So getting a mini model that's tuned, or a micro model, it's a similar process, right? It's just a question of how big, what is your choice, and that's one of the reasons why you can use, if you want to train on ChatGPT and use their 175 billion parameters, you know, Microsoft would love to be able to charge you per token, as far as like basically per unique instance. Like if you have, 5,000 documents, each has a matter of 100 documents, right? 100 tokens in them, right? That's 500,000 click, 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 ka-ching, ka-ching, ka-chings to train your thing on top of the compute cost, on top of the GPU cost. So it's a good business to be in, right? But also you're giving away your work, right? The nice thing about the ecosystem from Hugging Face and these other models is that they're open source, right? You can download these models; they're only a few gigs, and you run them on your hardware, and your data never leaves your firewall, right? I mean, if you want to open up a port to be able to have it trained, right, that's another thing. But the bottom line is that's so as an example, right? In order to train the gardening data set on the Dolly on the Dolly model, that's about 4 minutes, and that's pretty much all it takes, right? So in a lot of ways, because there's so, the P in GPT is pre-trained, right? It's generative pre-trained transformer. So in other words, all the major heavy lifting is to get that compression of consciousness, for lack of a better term, into a series of model weights, right? And be able to, I mean, it's lossy compression, to be sure. I mean, just to give you an example, I tried to use, anybody who has not used ChatGPT, who says they haven't used ChatGPT, is probably lying, because they don't admit they've had to use it, right? For simple stuff like plumbing in basic Spark SQL and Python, I mean, I tell my students, ask ChatGPT to give you a tutorial on Python, and just tell it what you're struggling with, and it'll give you great examples, right? But if you start to ask it to do like Scala examples in Spark, or understand very edge case like digital twins in Azure, right? Things that hardly anybody's using, forget about its accuracy, right? Incremental learning, right? Basically, what some people call online learning, like instead of having historical data, to have a model that's constantly being retrained. I think I asked ChatGPT for about places, what libraries were available. I think they gave me 10 choices, and 6 of them were wrong. So again, it's that edge case thing, right? But anyway, so the point, I think that the original question was just, what does it take to be able to build a large language model, right? And that's just the basic process, right? It's a little bit more, you're basically doing two types of, if you use either two types of transfer learning or three types, depending on whether you count the text summarization and then the sentence transformation and then the actual pure transfer learning from the large language model to build what you're what you're querying, right? So that's in a nutshell the what it takes, but like the devil's in the details, right? Because there is a whole, trying to be able to get good um, models that are trained easily without a lot of iterations and things. That's where you have this PEFT or parameter efficient fine tuning, and also FT or RLFT, which is reinforcement learning a feature of fine tuning, which is basically when you put a human in the. Yeah, I'm sorry. RLHF is reinforcement learning for human feedback.
Human feedback.
Yeah, right. Which is basically where you give people responses from the model and then you have them manually weight, because I mean it's still, you still need a human in the middle to give feedback, look and say, okay, this is a good response, this is a bad response, let me give you a better one, right? And then you use that information to retrain the model, right? So those are things that usually happen after your first draft of a model. But when you have, with for most conversations, for most business cases, it's you can it's not going to take a lot of tuning to be able to have some proof of value that is usually enough to be able to say, show to an executive and say, hey, well, we spent $25 of compute and we've got 3 out of 8 of our scenarios working. It's going to be $500 of compute. I mean, we usually tell customers you should expect in the entire life cycle of the work to be able to do somewhere between $2,000 and $3,000 worth of just raw compute GPU rentals. Whether it's Databricks or not just depends on whether you're how much you're committed to like the Delta Lake infrastructure and big data, and whether you want to use. I mean, I think it's public enough that I can say this, but they're actually at right now. If you serve models right now, they're only CPU in Databricks, but they're adding serverless GPU SKUs. They're announcing it at. I think it's been in gated public, so maybe it's been leaked already, but I'll confirm that here as well. So it's certainly. I mean, if you think about what it would take to have done the same work 2 years ago. 2 years ago, you had been building a sequence to sequence transformer, tuning layers and tuning batches, and pulling your hair out just to be able to get to something that worked just for your work, because you were only able to. There was no transfer learning that was available, right? So it is a welcome um, advance. But one of the hard parts is deciding, okay, do I use Eleuther AI? Do I use Vicuña? What do I use? One of the wizards? Do I use Code GPT? Right? I mean, what is the right mega model or mini model that I use for my personal use case of a micro model? So anyway, so I think that answers your question as far as
Yeah.
sort of LLM 200 in trying to help demystify the process. In very block terms. I mean, there is one last thing I'll say is that there is a thing called the language chain, which is a way to help build. If you want to have larger conversations, a lot of times,
Continuous thoughts.
yeah, you'll have a large, basically, so you can have a larger input and a larger output come. That's another class of kind of helpers for the basic transfer learning. So essentially, you're generating a language chain. So I think ML Flow in March 23rd was the first time that ML Flow, which is the most common open source platform for being able to train models, track experiments, and be able to serve them. That's when it started to support LangChain and transformers. But right now I'm having to. I have one bug open with ML Flow on their support for LangChain. And now I have to open up a LangChain bug because I finally got a version that would work with the subclass, but it only, basically in that chain that I talked about, right? It captures the hook to the GPT to the micro or the mini model, but it doesn't read the database to make it a full end to end pipeline for the transfer that it's showing. So it's to be continued. So let me stop there.
Yeah, well, you brought up a lot of good points there, and a lot of technical details, and one of the things is a lot has changed recently when it comes to you mentioned the transformers, that being a big change, and then also and this is you're going to bring a smile to that, Steve, but the hardware, what it took to run it. If you want to run any type of AI model, your hardware, and the transformers, and then the other is the advent of the GPUs. They with the A400s, with the what they use to power artificial intelligence had to be developed from scratch. These are custom hardware, and that hardware is Asif's favorite place to go. So Asif, you know the changes in hardware, what it takes
Oh
to
yeah.
support AI.
Yeah, I think we're drawing a map here. We're drawing a visualization for people to understand. And let me start off by this: like, who needs to understand all the things that Drew, Lucky, and me were talking about? It's not just technical folks, right? It's a finance officer that needs to be involved in this conversation,
Mhm.
right? Not that they have to have the attention the whole time, but they have to pick up on this fact that there's a difference between CPUs and GPUs. There's difference between where is this computing happening? Is it happening
Mhm.
inside of my building? Or is it happening in the user's device? Or is it happening in a data center out in Ohio? Right?
Mhm.
All things matters, and all things matters the way it is today. It's not how it's going to be in the future also, right? So does a finance officer need to know all that? I bet they do, because they'll have to pull the trigger to say, what's the cost, right? And then all of a sudden you have CIOs that are discussing the topic. Well, we're going to have a different frame of conversation. Attention will shift from CFO conversation to CIO conversation, but we all have to have all of them in the same room, because we cannot have this conversation in silos. We cannot have this conversation close behind the door, one way with CEO and another way with CIO. And then the junior guys are going to get stuck with the ideas that, well, did your language chain, right? Did your thought process continue the way it should have? That iterations, did they change in silos, or did you do them all out in the open, right? That I think was so important off of Drew's conversation we just had right now, is that, look, pre-trained, that's already done for you. What you do next is so important and so time sensitive, right? How do you execute that transformation, not 3 years from now, but overnight? You have to do that out in the open in front of your whole team, and have this conversation out in the open, because you're not sitting there thinking like, well, my competition will not do what I'm doing, which is, I will do it in silos, so they will. Now the culture is changing when it comes to data structuring, data capabilities, and data in a portfolio. So when you're having this conversation out in silo, well, when you have conversation in silo, it takes months and years. But when you have it out in the open, you have a different reaction. And the hardware conversation, look, not everybody gets excited about hardware. Some people do. And that's a perfect example of the conversation to have, because to me, software is very convoluted, right? It can go down a rabbit hole that I cannot retrieve from. But a server is about 5 inch stacked and 2 inches in the width, whatever the case is. I can handle that. Like, that's not the rabbit hole where the software will take me. So people like myself will need to be in that room. People like somebody that says, like, don't worry about the hardware piece. I'll figure out the infrastructure for you. You just do what you got to do. I'll do the plumbing for you. You got to do your data acquisition right. How do you feed that data through the pipeline is what I'm worried about, right? So I'm going on about these, but I want to just simply say what we talked about earlier: the big bubble and the small bubble. If the big bubble is to say pre-trained information is already out there available, how are you, the small bubble, who's going to take care of yourself by having a connection with a big bubble, right? So when it comes to Chat GPT, a large language model, it is trained, it's pre-trained to understand what a grandfather is, right? But if it starts making mistakes like grandfathered in on a clause that is a highly sensitive document, right? You have to understand that, like, okay, I didn't really know that grandfathered in ChatGPT is different than the grandfathered in my contract, which is, say, you're in a lawyer's office, right? But also, let's say another example is ship, right? Well, ship, you got it all over the world, right? but it matters differently from organization to organization, right? Because if you're in a shipping lane business, you have to have a ship that moves in the water. But if you're a FedEx, your shipping is not the same as a shipping lane, right? So these terminologies, how do you train your small bubble to work with the big bubble, or work with a bigger pre-trained system, for your pre-trained system? You have to have these sort of adaptation that needs to happen very fast and rapidly, just like AI machine learning is having multiple generation in less than 5 years. Well, that's not going to change anytime soon, because Stanford has a $600 large language model that is ready and available for people to use. I think unfortunately they shut it off because it's not secured. But whatever the case is, you are capable of just talking about a few $1,000s here and there to get your company going in adaptation of large language models and capabilities that comes with it, right? Based on the question you asked about the hardware, look, um, hardware piece where we are today and where we're going to be has to be a major topic. And this is why I love hardware, because where it stands today, it might not be here tomorrow, right? The GPUs that you see with NVIDIA, that you can rent and borrow, right, will not work for your cell phone users, right? So if you're a big organizations that are thinking of like, well, it works very well in NVIDIA chips, but how would it work in a RISC or ARM inside of your phone? Right? How would that process information on the edge, right? So do I need to worry about having a machine learning pre-trained system that is inside of your phone? And how do I deliver that? Right? Am I competitive enough to deliver that overnight? Right? So this kind of conversation about the hardware is something that you have to bear in mind. Just because something is exciting, you have to look at it from a bird eye view, maybe a satellite view. I don't know, whatever the case is, to say, how do I incorporate this down the road? How do I incorporate the hardware that's ever changing? Might not be as fast as a large language model or computer vision or a foundation model, but the hardware changes are coming, and they're coming very rapidly. And you will have to adapt to them in the future, no matter what sort of large language model or foundation model you build today.
Yeah, I mean, to your point, right? A mega model or a mini model is not going to fit on a phone, right? You're talking about gigabytes of memory and the amount of horsepower GPU wise, right? I mean, I think, technically, I think that you could argue that the Apple Silicon is is sort of an inflated version of an iOS hardware, right? But even there, it's not going to, even though you could potentially squeeze out that extra RAM for their GPU implementations, it's not the same because the between the power consumption and the amount of bandwidth necessary to move it back and forth is not going to cut it. But I mean, when you look at the micro models we talked about, like what actually gets delivered from you doing your transfer learning, you usually have those models terms of in megabytes, right? Which means that you've got a shot at being able to have that be on a mobile device. But to your point, there is an ecosystem that you have to be aware of, and also, I think that old school people will be like, well, why can't I use my $500 i7, right? Well, an i7 has an 8 megabyte level to cache, right? Which means you may have 64 gigs of RAM, but as far as when you're actually doing computations, it's only looking at 8 megabyte chunks, right? Deep learning, right? You're doing a lot more math, a lot more parameters, right? You need minimum 8 gigs, usually, like I said, 24 gigs of actual, like basically instead of, driving a mini coupe, you got to drive a bus full of data back and forth for your calculations there. So, it's a paradigm shift. I mean, you talked about as far as cognates in history, right? I mean, I'm not really sure we can. I mean, even the printing press doesn't. You know, the printing press just made it easy for a very small, rich number of people to be able to learn better and faster. And the first, few hundred years, and then ultimately, you could argue that printing presses, were probably what helped, the revolution happen against, the Russian Empire, and other things. And then people started to get smart, and then they, pushed disinformation the other direction to to make it easier to control people, right? So, you know, I don't know. It's exciting, but it's also it's frightening, right? There's a lot of reasons when there's so much uncertainty and so much power that you have you you know you can't see on how it's made, that people can be worried. You know.
And I think I just want to hit on another topic. You said mini that has to drive with a bus behind it in order to process data, right? I give you one another example. That analogy was I was thinking about earlier. Is that you will have closed off system that you have to subscribe to get into, because that will be built with security and the other open source information that are not built in security. So I think you will have to go to that period of time where it's not available on your phone for you to do large language model today, or it's not available on your phone to do AI machine learning capability today. However, until then, might be a point where you have to drive Ferrari from home to the next gas station and then park that Ferrari and take a clunk of car to get to the office, because you have to see like reverse that scenario time to time to say like you take a open source information and you study and you research and you get a broad topic like Ferrari, right? Like all those super juicy stuff. And then you have to log into a system that is closed off and that has like a very little amount of information, and because it's security heavy, right? And to say like, okay, how do I confirm what it is that I need to know, and how do I approach that, right? So that's your clunk that it's not really something you take into the office, right? But your open source is just that big. It's very hard to maintain, very hard to keep up with, very hard to stay keep your attention in, right? But what works in what works in the office is a clunk, right? Work works in the office is that the secured environment, one that you cannot do much in, you cannot play a lot in, right? Because it's a secured environment. You don't want to draw attention. You don't want to bring the unfriendlies in, right? So I was just thinking about that Ferrari and the clunk scenario. And I'm glad you brought up that Mini Cooper and a bus scenario, because that's what we have to might deal with for that uncomfortable pain of growing, the fact that we we might have to figure out a way to say, how do we make open source that Ferrari as effective inside the office, just like it is in my personal computer, just like it is in my kid's laptop, right? Or in my grandma's laptop, so that way my grandma is able to say, well, that caller that just called me is definitely fake, because I can tell the deep fake AI versus regular human being. Because for a grandma to have that capability, how do you create that open source environment that everybody can use it for specific use cases, right? And without going through that, oh, you got to pay $20 a month subscription to Chat GPT, or you got to pay for billions of dollars to have that capability built into your system somehow, right? So I think that's a very important visualization you brought up, that Mini Cooper and a bus scenario. Definitely appreciate that.
It seems that people, and this is a learning process. The layman, um, the public, what they get to experience from AI is that what is transformed, or not so transformed, but what is going to be available on their phone, and what's simple, right? At the end, there's going to be, simplicity is going to have a dollar value. But again, we know that you can access that same information without having to pay. And that's something that doesn't, right now, isn't transparent. You can access these models without having, but the thing is, you have to learn. So one is learning how these models work, or have it served to you through your phone, where you have to pay some kind of subscription. And that's where we're at now. That's, and it's fantastic. I'll be honest with you. It's one of those things that I enjoy, the fact that the public is getting smarter. Now, at what cost, who knows? At this point, what the cost, is that we're giving up. But it seems like people are getting smarter, or maybe not. Maybe they're giving up more of their privacy and what they do to computing, and then letting it. But at the end, we're getting better. There's something that we're improving. Large language models have become current now, where before it was a thing of Jarvis, it was a thing of dreams. We had Siri, Alexa, and those were great. But now it's becoming more where we are going to have a Jarvis that's not so much just playing our music, but it's going to be, our personal representative in some way over time. But as far as the public is concerned, now it is in the forefront. And that's what I wanted to cover today. Us as geeks, nerds, technologists, We know what AI is and what it grew from. It's just data and algorithms, statistics, and you're developing these models that give us something that makes us feel real, more human. And on the other side is you've got people that think there's magic. Now, it's this our computers are becoming sentient. They're becoming, and that's where it's hit the news. Our code now is alive. Is it? You know, reality
Well,
is, but to the public, AI is alive. And so
yeah.
I want to thank you guys. Today's been a great session. We're learning about,
What a session.
large
Yeah.
language models, and this was fantastic. Thank you, Drew. Um, so before I wrap this up, I mean, what do you guys think about, Asif? I'll hand it off to you.
Oh no, I was gonna say Jarvis stands for just a really very intelligent system.
Hmm.
I was gonna say just another really very intelligent system, but Jarvis will be focused, right? Just a really very intelligent system. Jarvis will be the focus for next 5 years to come because we want to be able to reduce the amount of hardwares that we utilize for our engagement, the user experience that we have today through a laptop, through keyboards, through mouse. We want to be able to reduce that amount of hardware by having voice AI take
Hmm.
over all of our interactions with the system, right? And that is a large language models 101. Like, how do you take it to level 1,000 from large language model? Well, nothing really has to be large language model anymore. It's behind the scene playing out the voice AI that we'll be utilizing as a Jarvis for our day-to-day experience. So your cars will have Jarvis in it. Your home office will have Jarvis in it. Wherever the case is, wherever in the world you are, because of fast data in motion technology, right? Fast data in motion will be able to provide you with all those assistance you need. And then how do you how do you have data out in Montana, right? That hardware is based on satellite like Starlink. It's able to provide you with the internet out in the middle of the woods, right? Or out in the middle of Pacific Ocean, right? Or as you're flying an aircraft over the ocean, you're able to have an internet connection without any disruption. So data in motion will never be a problem in coming years and decades because these are the hardwares that are bringing the edge to the edge.
Hmm.
Right? Talk about a bleeding edge. It's in your edge, like it's literally built into your system somehow. So I think we'll work it out to a point that not to have Jarvis will be my big concern to say like, well, if we didn't do Jarvis in 10 years from now, we didn't do feature right, and that's where I'll end with
Well, I got one more little message I want to leave with is that AI has given us a huge leap forward in content of what we can ask a computer to do. The problem is that context wise, right? You know there's the more productivity that is generated by being able to create chatbots that can go after what used to be white collar jobs after we've automated blue collar jobs, right? Society has a reckoning that is coming, that the amount basically the benefits of this productivity are not distributed, nor is society properly restructured to be able to handle the amount of automation that is coming. And there's a reckoning that's going to have to come. These reckonings will come smoothly if people have conversations and they're inclusive, or they're going to be rough if people keep getting the short end of the stick. So just there's garbage in, garbage out, and if it moves too fast without considering what it's the repercussions, it can be a problem. So anyway, just wanted to leave that food for thought.
Ay, 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 ay. So much to talk about. So, Drew, we started off with ringing the bell, but you got to do the chant now. Like, where are you with the chant, brother?
The chant?
Yeah.
Okay. Let me see. I didn't warm up, so I could be better, but I'll give it a shot here.
Give it a shot.
Fantastic.
Well, I couldn't beat that one. Well, thank you guys so much for joining on another episode of AI, where we start off with one side of AI and we end up on the other. And somewhere in the spectrum, we learn something. Thank you all for joining us. Thank you, Drew. Thank you, Lucky, for making the time today. We'll see you guys next week.